Welcome to iOS Insights, the channel for iOS app development using Swift UI and Swift. The iOS Keychain is a secure and encrypted storage mechanism provided by Apple to store sensitive user data, such as passwords, authentication tokens, and other confidential information. It ensures that this data remains protected even if the app is uninstalled or the device is restarted. In this tutorial, we will explore how to utilize the iOS Keychain within a Swift UI app. We will learn how to store and retrieve data securely, ensuring the user information remains confidential and safeguarded against unauthorized users or access. By the end of this tutorial, you'll have a foundational understanding of integrating iOS Keychain into your Swift UI projects to enhance data security and user privacy. This is the application that we will be building. It enables the user to log in. So to log into the application, for the moment, we just type in test@test.com, but you can always change this later. And because the password is stored in the keychain, we don't need to enter the password again. As soon as we click on enter, the password is retrieved from the keychain securely. Let's encrypt it, and then we click on the login button, and then when we click on the login, it enables the user to access the onboarding screens. So the onboarding screen is what is protected via the login page. Without logging in correctly, you're unable to access the onboard screen. So this is the application that we will be creating in this tutorial, just to demonstrate how to secure a page or a service within your application. The first thing we need to do is create a user struct to hold the username, email and password. So to do that, we just right click and then we click on new file and click on Swift file, click on next and save the file as user, and then click on create. And then now type in struct user let email string and let password string. And now the next thing we need to do is to create a user manager class. If we want to, we can do it in the same user struct, or we can separate it, but just do it in another class, in another file. So just create another file, right click by clicking on the control key CTRL and click on new file. User manager, the name of the class, and click on create. Class user manager static let shared user manager. This creates a shared singleton instance of user manager. and let's type in private var user email. Let's give it the email, which is test@test.com. Password test, and then create another user 2 at example.com, and then put a password to type in ABC. And what this does, it just creates an array of sample users with email and password. You can also add more if you want to. And then I think there's something missing. What's missing on it? User email. Oh, forgot the comma. The comma should be there to separate each record within the array. But really, the users should be coming from an API. Really it shouldn't be hard coded or coming from a database somewhere. Even if the database is on the device, it shouldn't really be hard coded. But this is just to show, for example, function is valid user email string password string bool return users contain user in Swift user dot email is equal to email and user dot password is equal to password. So what this function does is it just checks to see if the user email and the user password that we provided, just check to see if it's in the actual array. And then if it's in the actual array, that means the user email and user password is found, and then the array will return true. So the isValidUser function returns true if it's found, else it will return false if it's not found. Just compile it just to make sure it's correct or that it compiles. And then the next thing we need to do is create the keychain manager class. So to do that, we just create another Swift file. Call it keychain manager and then We also have to import security because we're going to be using the keychain. So we're using the security framework. Next we create our class keychain manager, static func store credentials. Store credentials in keychain. Username string, password string. If let password data is equal to password data using .utf8, on line 14, what this does, it creates or converts the password string to a data type using UTF-8. Let query string any what we're doing here, we will be creating a query dictionary with keychain attributes for storing the passwords. So just type in k set class as string k set class internet password. Then comma, then k sec attributes, attree account as string username the k should be lowercase k, then k sec value data as string password data. So on line 16, that specifies the class of the keychain item, as we're using the password internet class. And then on line 17, that specifies the account or username to store. And then, so the account that we'll be storing is the person's email address. And then on line 18, that specifies the password to be stored, which is the actual password that we're typing in to be authenticated against. Next thing we need to do is type in let status is equal to sec item add query as CF dictionary .nil. On line 21, it attempts to store the password in the keychain using the query. That's why she's using the sec item add method. If status is not error sec success, then print error storing credentials in keychain. Status. So this function that was done, that stores the username and password to the keychain. The next function we need to do is to get the password from the keychain using the username. Create another function which is static function func get password from keychain user name string. If the username cannot be found, it will return an optional so that the application doesn't crash. That's why we put a question mark here on line 28. Var password string. Let query string any set class as string sec internet password and comma sec attree account as string username sec return data as string kcf boolean true sec match limit as string sec match limit 1. So on line 33, line 32, it creates a query dictionary with the keychain attributes for retrieving a password. It's a little bit similar to what we've done here on line 14. And then on line 33, it specifies the class of the keychain item, and then the next line specifies the account username to search for, and then on line 35 it specifies the actual password the data should be returned. On line 36 it specifies that only one matching item would be returned. So now we have to create another variable to store the results. Results, any objects. Let status equals set item copy matching query as CF dictionary. CF dictionary is a Objective-C data type. Where you see CF, it's always Objective-C data type that we're using within Swift UI or within Swift. Ampersand results, so just pass it by reference or as a pointer. And then what we need to do next is, so this attempts to retrieve the password from the keychain using the query. And now we'll check to see if the password was found. Type in if status equals error set success, let data equals results as data. And what this line does on line 43, if the retrieval is successful and the result is a data object, convert it to a string. That's what we're going to do now. So password equals string data encoding UTF-8. And then the next thing we do is return the actual password to the user that was retrieved or fetched from the keychain. I'll just compile it now. So next week we'll be implementing the UI using Swift UI so that the user can enter their username and password using text fields, and then also implement the onboarding functionality as well. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.